Good morning. Today we are going to discuss about the unconformities. Unconformities are the very important structural features in structural geology, and it has a wide significance in geology. An unconformity is defined as a surface of erosion or non-deposition, which represents the break in the process of deposition. So basically what unconformity is, it is the margin which actually represent the break in the deposition. So basically two processes happens alternatingly. If the surface area or the surface is submerged under the water, the surface experiences deposition. But if the surface is exposed to the atmospheric agencies, then erosion happens. So at a given instance of time, a surface may experience a deposition or may experience the erosion. So, what unconformity says? It says that it is the break in the deposition. Say, for example, the surface is experiencing the depositional process due to its submergence because of certain agencies, but due to some tectonic activity, that surface get uplifted, okay, and the depositional environment is no longer present there, and now the deposits what the depository agencies made will suffer the atmospheric agencies, and those atmospheric agencies will further performs weathering and erosion. So so for example, you have a conformable series. As you know that A, B, C, D, E are the conformable sequence. Means you know that after A, B comes B, after B, C, and then D, and then E. What happens if I give you a set of A, B, D, E? So I gave you the bed of A, B, D, E. Then you will understand that a bed is missing. So A, B, C, D, E. The C bed is missing from the sequence. And hence that sequence will be called as an unconformable sequence. So what actually happened to that C bed? That C bed would have been eroded by the erosional agencies, and because of which that C bed is removed from there, and directly we get D bed after the B bed. So such type of series is called as an unconformable series, and the margin which actually differentiates or departs these two sequences is called as an unconformity. Let us see the process of formation of unconformity. In the picture you can see that there were mountains. These mountains were uplifted, and of course they experienced weathering and erosion. Now, due to continuous weathering and erosion, the upper layers were removed, and now there are plantation, trees, and animals roaming over there. And in the last stage, when this surface will again experience the depositional environment, new beds will form over there. So, when you will observe and when you will correlate these sequence with sequence where it is conformable, you will find that some beds are missing or few beds are missing. So you can easily say that the margin from where the beds are missing is an unconformity. Okay, so it actually represents the time gap. Okay, it can actually represent the time gap that this much of time was there where when there was no deposition, and if there was no deposition, then there would have been an erosion. Okay, so this is the process by which the unconformity is formed. What are the types of unconformities? We have five types of unconformities: angular unconformity, disconformity, non-conformity, regional unconformity, and local unconformity. Let us discuss about them in detail. Angular unconformity. In this type, younger and older rock formation have different angles of depth. So here we know that there are two sets of bed. One is above the unconformity and another is below the unconformity. And that unconformity represents the gap in the deposition. If there is the difference or significant difference in the deep angles of these two sets of bed, in that case, that unconformity can be called as an angular unconformity, because the lower beds or the upper beds will have entirely different deep with respect to the other set. So they are having an angular interrelationship, and hence the name angular unconformity. In the picture, you can see that the lower set of bed is highly inclined, whereas the set above the unconformity is horizontal in nature. So it is very clear that when the lower beds were formed, they were also they would have been horizontal, but due to some tectonic activities, they became inclined. And after the inclination, that those beds would have experienced the upliftment and the subsequent erosion. And after that, after a considerable length of time, thus the surface which has experienced erosion again experienced the submergence. And then the top set was deposited. So of course, there are certain beds which are missing from this angular conformity, and hence the relationship is angular between them because their depositional environment and depositional times are different. Disconformity. In this type, younger and older rock formation have same angle of deep. So now, in angular unconformity, it was very easy to differentiate between top and bottom sets. But in disconformity, what will we do if there is the same angle of deep among the all beds? In that case, you have to search for the erosive or erosional activities evidences, because you know that if there is an unconformity, that means the lower bed must have suffered the erosional activities. And if there were an erosional activities, then of course you may get some erosional evidences like the presence of soil, presence of regolith, cobbles, pebbles, etc. So when you find the evidences of erosion like erosional soil, cobbles, pebbles, gravel beds, then you can mark that that horizon is an unconformity, and the top set will be the younger and the lower set will be the older. Now you have to correlate this set of beds with the other set of bed where the series is conformable. Then you will come to know that how much time or how much span of erosion was there, because you will find that in conformable series there were 10 beds, but here you are getting only 6 beds. Then you can easily say that the 4 beds are missing, and you can calculate the by geochronological tools that how much time uh, there was a gap in the deposition. The third one is the non-conformity. In this type, the older formation are igneous plutonic rock. So in our early two types of unconformity, we have seen that the the both sets were of sedimentary origin. But here, the top set could be sedimentary origin or could be some other origin. But the bottom set is of igneous origin. So if they are igneous in origin, then of course there is no question of bedding planes or no question of deep of the bed. And in that case, in this case, such type of unconformity is called as an non-conformity. It is a type of unconformity, but it is a non-conformity. And of course, that plutonic igneous rock may would have experienced the erosion activities. Okay, but only the basement is made up of igneous plutonic rocks, and the top sets would be of sedimentary origin. In that case, such type of unconformity will be called as non-conformity. Regional unconformity. Regional unconformity is very important to understand because such unconformities are traced throughout the world. The well-known example is KT boundary, Cretaceous Tertiary boundary. What actually Cretaceous Tertiary boundary is? It actually distinguishes between two sets of bed where the beds below indicates the fossils of dinosaur, whereas the beds above does not show any evidence of the dinosaur fossils. So what actually it represents? It represents that KT boundary actually signifies or indicates the extinction of the dinosaur. And you go throughout the world, you can trace this KT boundary throughout the world. Okay, so this boundary, this unconformity is an original unconformity. Okay, you will not be localized with this unconformity, Wherever you go, you may go to America, Australia, or somewhere else, you will find the same characteristic of this unconformity. The local unconformity is the unconformity which is reserved for the local areas, which cannot be traced regionally. Okay, so local unconformity is the contrary of the regional unconformity. So this was all about the unconformity. Let us revise it in short. Unconformity is the surface of erosion or non-deposition which actually represents the break in the process of deposition. So another definition is an unconformity is defined as a surface of erosion or non-deposition which represents break in the process of the deposition formation. You can see that how the unconformity is formed. You can see how the top beds are there, which are removed because of the erosion. And after the submergence, the new beds were formed. So there are some missing beds over there. And in that case, that margin is referred as unconformity, and it represents the gap in the process of deposition. So there are the types of unconformity. Here is the angular unconformity, disconformity, non-conformity, regional unconformity, and local unconformity. Then we have seen angular unconformity where the top set and the bottom set have different deep angles. In disconformity, the top and bottom sets have similar angles of deep. In non-conformity, the lower set of the layer lower set is made up of igneous plutonic rock, whereas in regional conformity, the conformity which can be traced throughout the world will be referred as regional conformity. On contrary, the unconformity which is reserved for the local areas is referred as local unconformity. Unconformities have a great significance over the geochronological studies and in the historical geology. Most of the stratigraphical studies are always done in reference to the unconformities. So this was all about the basics of unconformity. Thank you very much for your patience listening. Thank you.